Hello guys and welcome to today's video. Right guys, in today's lesson, we're going to be looking at like reoccurring decimals. So this will be part one actually, hopefully of like a two-part like lesson here for like reoccurring decimals. Okay, so for today's lesson, we're going to introduce the idea of what a reoccurring decimal is, and then I'll be going through like two examples of how to express reoccurring decimals as fractions. Okay, right guys, if you're new, welcome. My name's Abdallah and I'm a private maths tutor and a qualified maths teacher. Okay, I make maths videos here for Key Stage 3, GCSE, A level and Key Stage 2. Okay, yeah, please do subscribe here if you're new and then drop the video a like and also enable notifications. But we will get on with like today's video, guys. Right, guys, so reoccurring decimals, okay, so part one of the video. Right, so we're looking at like GCSE higher tier for grade 6, 7 actually, yeah, for the curriculum 1 to 9 GCSE specification. Right, so a decimal. So in our first video, guys, when we looked at decimals recently, so decimals are what we call like part of like a whole number. So it is something that has like a decimal place. So it's not a whole number, it's part of a number. Okay, decimals can be expressed as fractions, yeah, and percentages, okay? And I have done a video on that like a while back actually, so I will leave a link for that in the description below. Okay, right, guys, so we're looking at what is meant by a recurring decimal. So a recurring decimal, guys, means it's a decimal that goes on forever. So if it has that dot here, so sometimes on your calculator, you might see like this like little notation, like a little dot. If it has a dot here on top, then it means that number is repeated here, like essentially like indefinitely. So it goes on forever. Okay, so reoccurring means that it goes on indefinitely. It goes on forever. Okay, so we'll be looking at this here for like today's lesson. Okay, so we'll be talking about how to express reoccurring decimals as fractions. Example one, expressing 0.7 reoccurring as a fraction. Right. I'll talk you through like the process actually and explain to you how to actually work it out. Right, so 0.7 obviously with a dot actually means 0.7777777 and it goes on forever. Okay, so I've put like a dot there. Okay, so it goes on like forever. Okay, if I say, guys, if I let R, okay, so R is just like a letter for like reoccurring decimals, so letter R equal to 0.7777777777777 and so on and so forth. Okay, dot. Okay, then I can say, okay, that 10R would be 7.777777, like, yeah, and so on and so forth. Okay, if we look here at my place value on my right hand side actually of the decimal place, okay, we can see that I can express like, so here all the sevens actually line up. Okay, so what I can do is I can do equation 2 subtract equation 1. Okay, so if I have 7 take away 0, I get 7. Okay, 7 take away 7, I get 0. 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 And you can see that all of them actually will actually just cancel actually and it will just give me 0. So I'll be left with 9R is equal to 7. Okay, 9R means 9 times R, so the opposite of multiplying by 9 is to divide by 9. So I get R is equal to 7 over 9. Okay, so my fraction would be 7 over 9, okay, for this recurring decimal. And you can check your answers by tapping that into your calculator actually to see if you get 0.7 reoccurring as your answer. But that is how you'd actually work that out. Okay. So it's like a nice little procedure actually. So it's like an algebraic like proof actually essentially, okay, to show that you can express reoccurring decimals as fractions, okay. Because sometimes you might be thinking, oh, hang on a second, if it goes on forever actually, then it's impossible to express it as a fraction. Okay, I can see like obviously like why that would obviously like why that thinking actually would like work actually, but actually obviously any decimal actually it doesn't matter whether it's reoccurring or not reoccurring can be expressed as fractions because obviously we can have like odd fractions. Okay, so like because the fraction 7 and 9 actually obviously 9 doesn't go into 100 actually, so I know that the decimal version actually it will be like a weird one actually. So like certain decimals obviously, yeah, obviously can be expressed as fractions a bit easier than others, depending on the factors of that number. Okay. So the factors of 100, okay, if the number doesn't actually go into like 100 like fully, okay, then that's where like yeah, I start having like weird like decimals actually, yeah, and potentially like reoccurring like decimals, okay, for that. Right, guys. Okay, so example 2. Express 0.862 dots here as a fraction. Okay, so the two dots here, guys, means that it's the 8 and the 6 that are repeating. Okay, so it will be 868686. So 0.868686868686868686, and so on and so forth. Okay, this time what I've done actually, okay, so I've got 2 bits here. So I've worked out what 10R is. So I've multiplied everything by 10. Okay, hey, so I've moved everything to one decimal place to the left. Okay, 10R equals 8.68686868686868, so on and so forth. Okay, 100R would be 86.8686868686868686, and so on and so forth. Okay, I would now stop actually and I would look actually at my points on the right hand side of my decimal. Okay, so if you look actually for the R and the 100R actually, I've got 8 take away 8 which is 0, 6 take away 6 which is 0, 8 take away 8 which is 0, 6 take away 6 is 0. So I can do this equation minus this equation. Okay, so that's just obviously yeah, like a way to actually work out actually. Obviously it will need a little bit of practice before actually like it is like practicing, yeah, obviously like looking at your place values and make sure that you get like the right answers like for them, if that makes sense. Okay, so 100R take away R is 99R. Okay, I'm gonna get 86 take away 0, which is gonna be 86. So my answer would just be 99R equals 86. Therefore, R is equal to 86 over 99. And that would be how I'd work out my reoccurring decimal for that one. Okay, so I hope that actually made sense, guys. Okay, like yeah, like obviously comment below actually if you've got any questions. But this is how I would express a reoccurring decimal as a fraction. Okay, so it involves obviously like yeah, like obviously a bit of practice on like multiplying decimals, obviously by like yeah, like by tens, hundreds, and thousands. So knowing obviously like your like place values. Remember that if you multiply a decimal by 10, 100, or 1,000, actually yeah, it moves according to how many like yeah, like place values you are like moving actually. So what I mean is if you multiply by 10, it moves one place value to the left. If you multiply by 100, it moves 2 places to the left. Okay, if you multiply by 1,000, it moves 3 places to the left, yeah, and so on and so forth. Okay, so yeah, so obviously make sure yeah that you're happy with that actually. Yeah, like that. So like multiplying obviously by 10, 100, 1,000, yeah, is quite nice and like yeah easy. But yeah, obviously it will involve obviously practicing that and also obviously practicing your like place values. So when I subtract the equations, I want to subtract the ones that will cancel out everything on the right hand side of my decimal and just leaving yeah like the like whole number and the yeah whole number on the left hand side and the whole number on the right hand side, if that makes sense. Okay. Right, guys, yeah, thank you for watching. Yeah, as ever, please do subscribe, yeah, and drop the video a like and enable notifications. Okay, and check out, yeah, obviously Maths Genie, Primus Kitten, Corbett Maths, Maths Chelsea, Hegarty Maths, and Exam Solution. Okay, thank you for watching. Stay safe. Bye now.